Welcome back to Cricket Aviation. My name's Jim Payne, and yes, it's been a long time since I've posted a video here on YouTube. So I had some house projects that came up that I needed to get completed, and once it became clear I wasn't going to make it to Oshkosh last year with this airplane completed, I decided to just focus on the house projects and then get back to the CriCri here as soon as I could. I've actually been working on the airplane for about the last month and a half. I have gotten a bunch of things done, and I know in previous videos I'd mentioned that I had a lot of videos coming up, which I do. But the next video in the series was going to be this video, which was the fuel tank video, and it turns out at about the time I decided to start working on the house projects and divert my attention elsewhere, I had all kinds of changes that I wanted to make, not only to the fuel tank, but also to the instrument panel and the throttle controls, and those were supposed to be some of the videos that were upcoming. So now that I'm back on the project, I have redone the instrument panel, I have redone a lot of the things on the fuel tank, and I've actually created new throttle controls. So all of those are done. In fact, my entire cockpit area inside this airplane is complete, except for the few things that still need to be done related to the flaperons and the flaperon controls. So I've got a lot done. I can now proceed with a lot of the videos I had sitting on hold, and this one here is going to be, as mentioned, the fuel tank installation. Now, I've done a ton of changes to my fuel tank that likely anybody else building a CriCri would not do. I've got a unique situation here with the turbines that I'm using, that it does require diesel fuel mixed with an oil mixture of 5%. I basically have to have my own fuel available, and it's not like this is an airplane that's going to be traveling from one airport to another and being refueled at another airport location. I'm not even planning on that even being an option. So I have set up my airplane to allow me to fuel it from the outside, but it does require a special connection. It's not like I can just pull up to a gas pump at any airport and get fuel. And you'll see that in the video here. I'm going to go over all the changes that I've done, which again, you might be interested, you might be not, because again, if you're interested in building your own CriCri, you might not be interested in doing these types of changes. So as far as the instrument panel goes, we'll talk about that in a future video, but some of the changes that I made was I had originally located the fuel valves on the instrument panel, which was a horrible idea, just because you're not supposed to mix fuel and electronics together. And once I started installing some of the electronics on the backside of the panel for like fuses and things like that, it was right in proximity of the fuel valves, which is not a safe situation. So I removed those off the instrument panel and actually created a brand new instrument panel, which again, that'll be in a future video, but I just wanted to let you know some of the changes there. And again, the throttle controls became an issue for me because of the sliding potentiometers that I'm using. They're not designed to have a lot of torque on them. They're not designed to grab onto them, bend them sideways, and put force on them. So I had to develop a throttle control system where there wasn't any direct pressure on those sliding potentiometers except sliding back and forth motions. So again, that'll be in a future video too, but I actually used a linear rail system and connected a throttle lever to that. And you'll see it when I bring the camera over here, because again, all of this stuff is done, so you'll get a sneak peek at it right now when I show you the fuel tank in the intro part of this video. But again, just be aware that's all going to be in future videos. So I'm going to go ahead and grab the camera right now and bring it over here. We'll just show you briefly what I've done with the fuel system. And then if you want to watch the rest of the video to see the details of what I've done, I'd appreciate it if you did. And again, if you're not subscribed to the channel, please subscribe, and please like the video. Let me grab the camera and we'll take a look. Okay, so we're going to start on the outside of the airplane, and you'll see here that I have created a remote fuel port that will allow me to fill the fuel tank from the exterior of the airplane. And this uses one of these zero drip connectors. It's basically you push it in and then you turn it and it snap locks into place. And it's got a fitting on the end here that I can connect to an external fuel pump and actually fill up the airplane externally from an external tank. And again, this is not practical for anybody except for me and what I'm doing here. It would not be practical to have that if you were traveling from one airport to another where you wouldn't be able to refuel your aircraft. So on the inside here, you'll also see that my fuel tank is painted. So I didn't like the looks of my fuel tank, so I went ahead and painted it. But then as a result of not being able to see visually how much fuel is in there, and you'll find out that if you ever sit in a CriCri and your legs are here, and the stick is here, you can't tell at all how much fuel is in that tank below half. So that was obviously very critical for me. And so you'll see I actually have a fuel gauge. Now I have a fuel gauge because I was able to install a LiDAR laser fuel sending unit. And it's actually made for the automotive market, but I've installed a laser fuel sender on the tank that seems to work fairly well. It's connected directly to the fuel gauge, and I'm able to see the actual fuel tank level in the tank. And if you look up underneath there, I think maybe you can see there's a hose connection in the back there, the one with the red on it. That's the one that goes to the external fuel connector on the outside of the airplane, which is, you'll see it back there. And I do go over creating that connector. You'll see I've got fuel valves now up there on frame 2, the little black lever on the left there, and there's another one over here on the right. That's for the left and right pickups and the left and right engines. And there's also a breather tube, again, right behind the instrument there, right behind the fuel gauge, that goes around and up here, and you'll see it's the yellow hose here that's then connected and goes out the bottom of the fuselage down there. So I did that on this side because if I'm remotely filling it from this port on the outside, I wanted to be able to have the fuel overflow out the breather tube to know that the tank is completely full, in addition to being able to look at the fuel gauge and tell that it's full. So I can also put a glass jar underneath there, or I can connect a hose to it so that when it does fill up, it just drains back into the tank that I'm using to pump fuel into the airplane with. But this makes it so that I don't have any fuel inside the airplane, as far as like a fuel nozzle and a cap here, and being able to fill it up inside, especially with diesel fuel. It's kind of stinky, and I knew that over time, especially because I have to fill this tank all the way up every time, that eventually there was going to be a spill, and eventually there was going to be diesel fuel in the bottom of the airplane up there, and I didn't want to have to try and clean that up or smell it for the next 6 months. So, so these are the changes that I've done. Again, most of this is covered in the video. Now, the actual fabrication of the fuel tank, I don't really cover that in this video. I will show you pictures of the plug that I made. But as far as creating the mold and doing all the fiberglass work on that, that's another 3-hour video of, that I wasn't going to go into. So you will see some pictures that I took of the the foam form of the fuel tank that'll stick in this video, and of course you'll see the fuel tank once I've popped out the 2 halves and have those in the airplane, and I'm trying to fit them in. This fuel tank here ended up being 6.1 gallons, so I was able to get it above the 6-gallon mark, which is what I wanted. Again, it fits in here quite well. I don't have any interference with any of the flight controls. It seems to work perfectly, and if I move the stick all the way forward, it does not hit the fuel tank sender there. So we'll go ahead and get into the video now, but again, appreciate it. Thanks for watching. Stick around if you want to see all the changes I made to the tank here. So I'm working on installing the fuel tank, and I've gotten a few steps already done. I went ahead and created the bracket here that is going to attach to the back of the fuel tank. I haven't physically attached anything to it yet to connect to the frame 2 here, but I kind of followed the plans, and I just made a bracket here with 3 rivets centered on frame 2 and bent it so that it's going to go down the front side of the fuel tank there. And then I just made this bracket here, which I'm going to fiberglass on the back of the tank, and I left this long and didn't drill a hole in it because I'm going to drill this hole into here once I get the fuel tank in and have this actually fiberglassed onto it, so I can make sure that it lines up correctly. I do have to put a couple of foam strips underneath the tank, which will raise it slightly, but I also want to fill the tank up
with water probably initially, just to make sure I have weight on it before I align that hole and drill it. And I'll drill it as if it was full. I figure that's I guess the best way to do it. I'm not really sure. But I'm working on these other attachment brackets that are supposed to connect onto frame 3 down there at the bottom. And I'm doing this because I got to figure out where I'm going to fiberglass an attachment point on the fuel tank. Now, I did make a set of these before. I didn't like how these turned out because I'm sensing there's cracks in here. I can just tell the stress on the edges of these, and these were very difficult to bend. You have to create kind of a sharp bend in there in order to get a nut plate in there. So what I ended up doing is I just made another set, and I bent the first one, and I went ahead and annealed this. So I put Sharpie on here, and I heated it up, and then quenched it, and then bent it around this little form that I created that's got a radius on either end, and it fits right up in here. And I just put it in the vise, bent over one side, and then clamped it and bent the other side. But I have one more piece I'm going to do here. I'm going to do the same procedure because this seemed to work pretty well. I'm pretty confident there's no cracks in this one at least. And I'll go ahead and get a second one made. Then I'm just going to position these down there approximately where they should be, but I might just try and get them as close to the tank as I can without making sure that I can still get a bolt down through it on either side, because again my tank is a little bit different because I created this myself from my own mold. So anyway, let me go ahead and bend the other one of these. I'm going to try and get these drilled out and get a nut plate in here, and then I'll go ahead and mark and drill the holes into frame 3. So I got the mounts in here for the sides of the fuel tank on either side. Those fit pretty well. Luckily, I was still able to get pop rivet gun in here on either side. I really didn't have any issues. I did have to take out my little vents on the bottom, but they pop in and out, fairly easily. Now this is one place where I did use a floating nut plate, so you can see the screw feels kind of loose in there. It's because I used one of these nut plates that floats a little bit. I did that because the bolt that comes down through here from the fuel tank might not be perfectly aligned with that hole. Those floating nut plates give it a little bit of ability not only to move side to side, but to tilt a little bit, and it kind of finds the center, so you don't end up stripping threads or anything. So I did that with both these, and so anyway, these are ready to go. So one of the things that's really nice about working with CNC equipment is you can cut something like this out, fairly quickly. It's got the number 10 bolt holes already in it. I've got 4 spots in this cut out for 4 bulkhead fittings that are for 3/16 inch hose. In this situation, I've got 2 pickups that need to be in the tank, but then I also have on the turbines, I have a return line for fuel, so it's got to be a completely closed loop system. And it actually turns out one of the engines I have is a closed loop one, and the other one is not, because one is a KingTech G4 and the other one's a G4 Plus, where they changed the fuel system configuration. But I drilled it for all 4 for now, and then I'll just cap off the one I'm not going to use as a return line at this point. But again, one of the nice things is you cut things out like this really, really quickly, and then you don't get nearly as upset when you screw things up and have to cut out another one that looks like that. So what I found out is I cut this one out, and I realized it's going to be mounted here on the back top part of the tank, but the strap that is getting epoxied into the back of the tank comes right up past the bottom of this fitting, and there would be no way to get this bolt hole in the bottom once that that bracket's installed, the bracket that attaches to this. So what I did is I just cut another one and just moved the hole moved a single hole into the middle. So now I've got 5 bolts instead of 6, and I think this will hold just fine, because what I'll do is I'll leave material in the center here in the tank, the fiberglass, and so then the only thing I'll cut out is the circles where these are going to go, or at least a little area in here, and I think it'll be able to seal just fine. I think I've got plenty of support on there anyway, so not a big deal. Just wish I didn't have to make 2 parts, but I'm going to go ahead and drill out the back of the tank then to try and get the bolt holes located on this. I want to get the nuts that I'm going to put on the back side inside the tank. because what I have to do is I want to drill these holes. I want to locate exactly where the nuts are going to go. And then I'm going to epoxy those nuts in place. Now what I ended up getting is some of these, they're nuts, they're nut inserts. They're not like a nutsert, so they're not like something that you use a rivet gun or whatever to pop rivet in. These are inserts like you would use in 3D printing parts. They have all kinds of grooves on them. I don't have them yet. They're supposed to be here tomorrow. But I think those will work really well embedded in the fiberglass because they have all kinds of grooves that prevent them from turning. And then what I thought I would use on the top here is number 10 bolts that I already have that actually are for holding on the brake the brake disc or brake rotor on the wheels, and they already have safety wire holes in them, so I can safety wire these in place because obviously there's no way to put a lock nut on it. I could put a lock washer on top underneath here, but since I have those pre-drilled heads already and they're the right length, I think I'm just going to use that. So let me go drill out the back of the tank and then I'll stick it back in here and check the fit one last time before I go back and start doing some fiberglassing stuff to finish up the tank. Well, I have all the mounts now ready to go for the fuel tank. So I've got the front mounts down there that I installed earlier. I do have to fiberglass something on the tank, which I'm not going to deal with at the moment. I'm going to try and get the nuts in place for this plate in the back, and then get this bracket for the back part fiberglassed in. I'm also going to get the nuts that need to be located underneath the fiberglass installed here. And try and finish up everything I need to finish up before I actually join the two halves of the fuel tank, because right now I can still pull this top off the bottom half of the fuel tank because I haven't glued it together yet, so I can get to all of this stuff from the inside. So this is a fuel cap that I decided to go with. What this is this is like an oil cap that you can get from like Summit Racing or Jegs. And it's got a really nice O-ring on the top here, and it's for fuel tanks and or oil tanks, something where you'd want to bolt something to the top of, let's say a steel tank that you made or an aluminum tank that you made, or in this case fiberglass. Now underneath here there is a really nice O-ring that is recessed underneath this cap that right now is pushing against the fuel tank. So I really like this setup. This is a nice way to do a gas cap instead of doing an integrated one where you're using like a plastic, part from a plastic fuel tank that you're fiberglassing into the fuel tank. This is a nice add-on. Obviously, I still have to cut the hole. The only drawback of this is very, very heavy. This is solid billet, aluminum, so it's quite heavy. This isn't too bad. But it'd be nice if there was a plastic cap or something that was really lightweight. That might be a little bit better. It looks really nice. It looks really good with the brakes because, again, it matches everything. That's not why I bought it, but I did have a choice in colors, though. I could have gotten this in this silver color, black, or red, I believe. But anyway, so we're going to go ahead and finish up the rest of these things on the tank so we can get the tank permanently installed. That's what my goal is. I don't know if I showed this before or not, but this actually ends up being the stop at the fuel tank for when the stick is all the way forward, and you can see it just rotates a little bit on it as it turns, which actually isn't too bad. I do need to put something on here to protect the front of the tank because that would obviously wear into it. I'm also going to take a little bit of aluminum off the front of this and probably take this all the way down to where the outside edge of that nylon bushing is, because if I push the stick all the way forward right now, I'm about 1.5 degrees short of full travel on the stick. It's not much, but it is a little bit, and it would be nice just to have full travel. Now you can see in the front here, I've got fairly good clearance here on the stick, and what's nice is the stick actually goes right around the fuel cap, which is kind of nice at full travel. So yeah, this is all working out really good. I have a lot tighter clearances here on the side. I made a slightly larger fuel tank than I think the original stock one was that came with some of the that you could buy if you were building a CriCri. In Europe, everybody seemed to have the same shaped tank. This one's a little bit different shape because it's a little bit more squared off here. and it's a little more squared off here. And so the volume of this one is going to be a little bit more. Now I'm hoping to get that 6.1 gallons like it mentions in the plans. I know the one that John made for me that was off of a mold from an original tank was only 5.5 gallons. So I'm expecting this to be a little bit higher capacity. But anyway, it looks like it's going to fit great. I've got good clearance here on the cables, which is good. I've got good clearance over here on the cables. Like I said, it's a little bit tight getting your hand in here, but you find out when you're sitting in the airplane and you're flying, you're only getting a couple fingers down here anyway to pull out, open and close those the vents on the bottom. And then the only other thing you need access to is to get to the front wing pins on this side, and there's still plenty of room for that. I mean, I don't think anybody who's flying this is going to have huge hands, because you're not going to be a very big person to begin with. So, but anyway, this is coming together good. I can't wait to get this installed and have it done and have fuel lines in here, because then I can go ahead and put the front canopy cowl on here. Now I have verified that if I have that front canopy cowl installed, you can still get the fuel tank off. If you move the stick all the way back, you disconnect the fuel tank, you can pop it up this way and you can get it out. So you know, for anybody who's had the question of wondering if you permanently attach this front cowling, if you can ever get that out, but you certainly can. And obviously you could if you took the whole stick assembly out, but we wouldn't want to do that, to just do maintenance on the fuel tank. But it does mean, well, you would have to remove obviously the instrument panel, pop the panel out and disconnect things. But you can get the tank out. And of course, once you get the tank out, you have pretty good access to the rudder pedal tray, especially right now because it's pushed all the way forward. I can slide that rudder tray all the way back and do maintenance on it, take it out. So the only thing that's nice about these access panels that I created here is that if you need to get into that rudder pedal area to do anything, without having to come in here, take the instrument panel out, take the tank out, and go that route, it's a lot easier to just be able to get your hands down in here, especially if you just have to replace maybe, let's say, the rubber bands or the bungee cords that are on the rudder pedals, or do some kind of adjustments or something. It's still nice to have these access panels to get in here. So let me go ahead and do some more work on the fuel tank, and I'll show you what it looks like when I get a bit further here, and hopefully I can get it installed in the next few days. So I got a little bit farther with the fuel tank mounts. I did get the mount on the back of the tank epoxied in. I didn't really like how this turned out. It looks ugly, but it works. Obviously it's not going to come off. But I did have some issues with this, installing this, so I did something different a little bit with the side mounts for the tank. So this mount here, I cut those notches in there, to get it to grip with the resin when it was glued in. But I ran into some problems because this part is thick enough that it was very difficult to get the fiberglass to lay over the top of this and have it fill in along the edges of the bracket, because there was just too much of a drop off there. And of course the viscosity of the resin is designed to maintain a super thin layer that just absorbs into the fabric. It doesn't like to build up. So I ended up with a couple of bubbles, and I had a really hard time keeping the bubbles out of majority of this. So what I did with the side bracket is I rounded the edges so that the fiberglass would lay over the sides better. And then instead of cutting the big notches, I just used my Dremel tool and just inset some notches into it without going all the way through it. And then what I think I'm going to do on the back side here is actually epoxy this with the Hysol 9460 to the tank, and then lay fiberglass over the top. Now the epoxy is very low viscosity. I'm sorry, very high viscosity, so it sticks and it doesn't move. I had issues with this too, because this thing just started floating all over the place on top of the resin that I did put behind it to try and bond it to the tank. But I think it's going to be better if I actually use the Hysol to glue this to the tank on the back side and then cover it with some layers of fiberglass. I actually think that's going to be stronger. So on the corners here, I did fit the tank in there. I did install the number 8 rods into the nut plates that are supposed to hold the supports on the side of the tank. And then I just kind of fit this in there to figure out exactly where it's going to go. And then I put a piece of blue tape kind of vertical with where the vertical line should be. And then I know this needs to be about 1/8 of an inch away from that, because I couldn't get the tape right up against it. But this is basically going to go about there. And I did bend this so that it conforms to the shape of the tank. So you can see it's got a curve to it, and it's actually got a little bit of a twist to it, but it fits nice and flush, which is good because I want to bond that as well as I can, and I didn't want to have to do a bunch of gap filling. But this seems like it's going to work, and then I can cover it with fiberglass easily. The fiberglass on the surface will go into these little notches that I cut on the side with the Dremel tool, and I think that's gonna work great. Like I said, I think bonding this on the back with the high sol is going to be a better solution than trying to just glue it in with the resin. Not to mention, when I put the high sol on here, I can just stick it on there. It's not going to move. Whereas, like I said, trying to keep the back bracket there in place and not have it move around while I was trying to put the fiberglass on was terrible. So what I'm going to do is put the high sol on here, glue it first, let the glue dry, and then I'll come back and put the couple layers of glass over the top. And I was trying to do both sides at once with the brackets, but I think what I'm going to do is go ahead and glue with the high sol this one on, let it dry enough that I can refit the tank into the airplane, and then make the bracket for the other side after this one's already, secured and fit, so that any slight movement doesn't misalign the other side. Because getting the tank in there, getting it fit right in the right spot, you've got foam strips underneath it. You're supposed to push it down, get it in the right spot, and then get it to line up with those rods that kind of float around. It's a little bit of a guessing game to figure out exactly where they should be to try and at least get the rods as vertical as possible and not have it pulling one way or the other. So that's what I'm working on right now. Let me see if I can get this glued in with some high sol, and then once that's dry, we'll fit the tank back in and start working on the other side. So I have both of the tank mounts in the front here epoxied to the tank. I've got this one here, and I think you can see this one over here. Yeah, this took a little bit of trial and error. It doesn't take much to be off on these brackets when you're installing them on the tank. So what I did is I kind of estimated where they went. I bent them to fit, and then I used blue tape, and I taped it to the side of the tank, and then I drilled a hole in it at approximately the right spot, but I did have to move the bracket around a little bit to get it positioned correctly over the hole. This bracket hole ended up being a little bit further out from the tank. This one ended up being a little bit closer over there just because of the fit of where that curvature was in the tank. But yeah, it doesn't take much to be off on these, and you start having issues getting the all thread to line up with the hole for the bracket on frame 3 there. So they look pretty good right now, and I do have the foam underneath the tank, strip of foam. I'm just using this, it's like an automotive foam. The only thing I did notice is this does add a significant amount of thickness. It doesn't seem like it because it compresses down, but it takes a lot of pressure to compress a long strip of this underneath the tank. Now this tank, when it's full of fuel, is going to weigh almost 50 pounds, so the amount of compression that's going to be on those those pieces of foam is significant. I'm even thinking that maybe it would be better to have a stiffer piece of foam that doesn't move much, so when you clamp this down, you don't have this compression that happens, and then depending on how much weight's in it. Because part of the concern I'm having is that I'm not so sure I can clamp down enough on these brackets to be able to compress the foam strip as much as it will be compressed when this is full of fuel. Maybe not, I don't know. I'm trying to push it down as hard as I can, but we'll have to see when I actually get it full of gas. Anyway, so you will notice that my tank is actually dull on the outside. I did because I had some of the weave kind of that didn't fill 100% on the outside. I did put a layer of resin on the outside of the tank, and then I just quickly went around and sanded it and used Scotch-Brite on it. Anyway, let me go ahead and finish a few things. I do have to get the fiberglass over the top of these brackets. I'm going to fiberglass these in, even though I epoxied them to the side of the tank. I'm going to put the glass over the top, and we're just going to finish fitting the rest of the tank and doing the final things, which is to polish the tank. I do have to finish the pickup tubes, pickup lines that are going to go in here. I'm waiting for some hose clamps that are supposed to show up today. I got to clean out the tank. It's actually dirty in there now. But yeah, I'm trying to get everything finished, get the actual plate mounted on the back of here with the pickups in it, and get it bolted in permanently. I'm not planning on removing it after that. And then I can just get to the hookups back here to connect to the fuel pumps, and get the gas cap screwed on here, and I think we'll be good. So let me finish fiberglassing the top of these brackets, and we'll kind of go from there. Okay, I'm actually almost ready to install the fuel tank now. I did want to get the pickups installed on the tank before I actually put it back in here. I just figured it'd be easier, and I'd like to get the tank sealed, at least on the front part here where the pickups are installed, and the fuel tank filler itself, because I keep dropping stuff in the tank. I keep getting dirt in the tank, and I don't want to have to take it out and clean it. So one of the things I did is I did a little bit more work on these pickups that I did on the lathe. I just got a 1/2-inch bar stock of brass from Amazon and just cut these on the lathe. But I cut some grooves, some circular grooves, to put some O-rings on here so that it doesn't make metal to fiberglass contact with the pickups bouncing around inside the tank. It's still going to hit in some places, but at least this will help cushion it, 90% of the time or more. So I did that. These don't seem to want to come off, so I'm actually glad with how these worked out. I just put one on each end, and it's something that I've seen before on RC model clunks, tank clunks. So now the other thing I did too is when I was test fitting the tank in, I was using this automotive type seal, and this is just foam. It will compress, but I found out that I couldn't compress it enough with the width of this stuff being on the tank, the front and back. I couldn't put enough pressure on it to squish it down as far as I wanted to. And I got to thinking about it, and in reality, all we need is just something between the metal and the fiberglass tank to just provide some kind of barrier. So what I did is I actually found this, and this was actually relatively cheap. I think 10 feet of this was like $12, and I got 30 feet of this for $6. So what this is, though, is it's inch, let me see, I think it's inch, what is this? 1.25 inches. And part of the reason I wanted to get something a little bit wider is I wanted something to run up the back side of frame 2 and come across the top, so that the tank could sit up against there, and then also I'll cut one a little bit narrower to go across here. But I could even put it on I was thinking of even putting this on the bottom of the tank, and instead of putting it on the frames inside of here, and that might be the better way to go. So I can just go on the bottom of the tank where this curvature is and just put this this tape in there. And this is really thin. I think it's only 1/4 inch or 3/16 of an inch thick. And what this is, as you can see, it's a camper seal. So it's designed for the camper tops on like a pickup truck. And again, it was very cheap at the store. So I think I'm going to use that instead, because I want the tank to sit as low as possible, and I don't want there to be a ton of compression that occurs to hold the tank down when it's empty and doesn't have any weight in it. I don't want it to sink down when it's full, because then the bolts could potentially come loose, or I got to cinch those down enough that it puts enough pressure on the tank to hold it down as if it had 50 gallons of fuel in it, which I don't want to do that either. So so I think this is going to work better. It's going to get me a little bit better coverage, and again, it's foam like what's recommended in the plan. So this is the first time I've had the tank completely installed with all of the installation brackets attached, and it actually fits really well. So I do have to put a fair amount of pressure down on this to compress the rubber or the foam seal or foam piece that I have underneath the tank here to get this bolt in here in the front. But I think that's good. You put down pressure, put that bolt in. These alignment of these pins down here, the all thread parts on either side, ended up perfect. So the alignment is really good. They're nice and straight. I was worried that they were going to be angled and not quite fit perfectly right, but the fit's good. I did cut those off a little bit. I think I cut, I think they're 2 3/4, I think, is what I ended up making mine. They're still a little long, but that's okay. And I don't have the permanent hardware in there because this is going to have to come back out. I just wanted to get it attached here and see that everything fit okay. The stick is good. It clears like I had always planned. The only thing I have is this little bolt on the bottom of my adjuster for the stick rubs just on this side of the tank. So it clears over here, all the way over here, but it's got this tiny rub right there. So I'm going to have to do a little bit of adjustment, or possibly I need to put a stop on here anyway. That's going to hit this. That'll be on the front of the tank just to keep the front of the tank from getting hit directly with that. So I might have to just put a little piece of support there or something. But I got to check the stick throw, which I think might be a little bit further right now than I need, which is the 25 degrees, I believe. But you know, the brake handle doesn't hit the fuel cap. It's very close, but it doesn't hit it. And the fuel cap comes off here, and you can see down in the tank. So I think this is going to work out really well. I'm actually quite happy with this. So I didn't install this permanently yet. I did attach the 3/16 fittings here basically permanently to the aluminum plate, but I haven't put any sealant behind the aluminum plate because I still haven't installed the pickup tubes. What I found out was that on these pickup tubes here, I need to put some safety wire around the base of these to hold the hose on, and I don't have any small enough safety wire to use with that. The 32 thousandths is just too big and stiff. So I'm going to order some 20 thousandths stainless safety wire, and that should work. And then I also have to safety wire these ends too on the back side of these 3/16 fittings. I had planned on using these little stainless clips, these little hose clamps, which actually work really well. But once I clamp the hose on the back of these fittings, this clamp will not fit through the hole that's in the fiberglass tank to fit this down in here and bolt it in. So again, I'm just going to have to unbolt this, pull it out, and safety wire the ends of these and make sure that the safety wire is wrapped, you know, tightly around the hose and the fitting so that it fits back through the hole here. So that wasn't going to work on there, but it will work on the top side here. So I'm probably going to use those you know, fittings to attach the hoses here on the top side of the tank, or the outside of the tank. So you'll also see that I have not installed a vent yet. I'm still trying to figure out exactly what to do for a vent. I know the vent's supposed to be like somewhere here in the front of the tank or something, but I didn't want to, you know, any of the stick to interfere with that line. And I'm thinking that if I were to install any kind of secondary tank, I would attach it to the vent line of this tank so that the other tank would feed through the vent line into this one, and then that secondary tank would be vented. Which means I need to put a vent in somewhere where I can route a hose somewhere else other than just down and out. Now, initially it will have to be down and out. But I'm thinking what I'm going to do is actually put a vent right here, a surface mount vent that comes underneath the tank from the top side here. That just fits and comes through, kind of a bulkhead fitting. In fact, I was even thinking of taking one of these bulkhead fittings and cutting the 3/16 barb off the other side and using that as a through fitting here, and then, you know, obviously you know, nut it on this side and then have the 3/16 sticking up that I could attach a hose to that would come somewhere behind the instrument panel and maybe down and out down here somewhere. Again, it's got to clear your legs can't hit it. And that was the other thing too. I just couldn't figure out how to get a hose in here that wasn't going to be in the way of your legs. It's really got to come up behind the instrument panel and back down through the side here, which is what I'm thinking of doing, and just having it come out maybe down there somewhere. I'm not sure. So I've been trying to figure out how to finish the last few things on this tank, and the two things I wanted to try and resolve was, first of all, the vent. And what I decided to do was just go ahead and install a vent in the top of the tank right here. I don't really have any way of integrating it in with the cap, and I didn't want to put it here on the front and have it in the way of the stick or anything, or the brake handle or something like that. And what I thought I'd do is just run the vent here. I'll run it up behind the instrument panel over to the side of the fuselage and down, and then back in front underneath the front of the tank here and out the bottom of the fuselage. There is a concern because you could probably stick that vent just about anywhere, but I don't want to have that anywhere in front of the air vents for the incoming air into the airplane, which are in the bottom of the fuselage right in front of frame 4. So I need to get it down here in the center between just the front of frame 4 but yet behind where those intakes are. So that's the solution I came up with. I don't know if it's the best solution or not, but it's what I decided to do now. The other thing I thought I would do too is have some kind of a remote fill option here. So what I did is I went with a bigger connector here. This is a 1/4 inch, and that's a 3/16. And I decided what I was going to do is just put one of those in the top here, and then I can run a hose over here to the side of the fuselage and have a remote fill port. Now, it's obviously going to take a while to fill up a 6 gallons of gas with a 1/4-inch fill tank or fill inlet, but I figured, well, it's better than nothing, and it's not like I'm going to be in a hurry to refill this thing and go for flight again. It's not that big of a deal. But anyway, these are the two things that I'm connecting right now. What I did is I just drilled a hole through the fiberglass part of the fuel tank, and what I'm going to do is just insert these inside from the inside with a washer on the back, and I'm going to go ahead and put some fuel resistant RTV that I have on these to seal them around here. I'll put some RTV around the top here, seal it around the top, and then put a lock washer and nut on the exterior here on both of these. So I think that's going to be fine for these two things, just for the vent and for the fill. I do have to now finish this back here. I just need to get the RTV on all of this on the bottom side of the plate, and then I should be able to screw this in here, and I'm going to seal around each one of these holes here just to give some extra sealant there where these come through on the back side of here. But that should be almost completely filled around there with RTV by the time I get done and filling this hole, so these aren't going to leak at all. And not to mention these fittings were actually put in here very, very tight. In other words, they actually almost were press fit into the aluminum. You could get them in and out with your fingers or by hand, but they were actually quite snug. So there really isn't any room, I don't think, for leakage around those and to come out the front. So again, I'm not worried about that either at this point. So I'm going to go ahead and try and get these inside. Now what these actually are is these are the same fittings that I used down here for these on the back side. And I actually just put them in the lathe and I cut one end of it off so I get a flat surface on the inside, to basically make almost a plug connector. But that seems like it's going to work just fine. Again, the vent should work good. So I'm going to try and get these two in, get the RTV on this and get this installed, and then I can actually reinstall the fuel tank. I'm getting ready now to finish the last few things that I need to do with the fuel tank. And I went ahead and purchased a few things, and I came up with some ideas of how to run not only the vent line from the fuel tank out of the airplane, but also how to connect a fill port so that I can fill the airplane or fill the fuel tank from the outside of the airplane. The reason I'm doing that is just because it's somewhat inconvenient to try and get to this fuel cap. Of course, you could open it here, you could put a fuel fill hose here. I'm just really trying to avoid having any gasoline exposed inside of the aircraft at all. Something that could spill. This is diesel fuel, it stinks. I just don't want to risk getting it inside of the airplane anywhere if I can avoid it. So my plan is to actually install on the outside of the fuselage here a flush fill port. And what I did is I don't have it yet, but I purchased it's a quick disconnect, but it's considered to be like a zero break connector, where it's one of these that you push in and then you twist and it just snap locks. They use them on brake lines sometimes, but what I decided to do is get one of those connectors. I'm going to mount it probably on the side of the fuselage underneath here somewhere. I'll create a little plate for it. I'll mount it on there. And then all of the connections from that connect to the fuel tank using ANN 6 fittings. So that's what I have here. Is I bought a kit of ANN 6 fittings, mainly because I needed a 45, I needed some straight connectors, and I needed some hose. And my plan was to use just a short piece of this hose to go from the side of the fuselage to the fuel tank. And then the rest of the hose I was going to use on the external pump and tank system that I'm going to use to remotely fill the tank from the outside of the airplane. So all of these are ANN 6 fittings. What I figured out is that I think it's 5/16 is like the standard tubing size used for most fuel pumps, like on an automotive car. And a lot of these pumps are 12 volts. It's very easy to create a pump system using one of those pumps on an external tank and be able to use that to fill this tank inside the airplane from the outside. So I kind of decided I'm going to plumb everything for that connection to remotely fill the tank with these ANN 6 fittings, which are about 5/16. Or 5/16 hose anyway. So what that means though is I had to get a new bulkhead connector here that I'm going to replace the 1/4 inch one that I stuck in the top of that tank. So I'm going to take the tank out actually right now, go ahead and take out that fitting that I put in there. I'm going to drill a bigger hole, and I'm going to install this ANN6 bulkhead fitting. This will be now the new fill port, and the nice thing is it's a little bit bigger, so it should fill the tank a little bit faster. But I'll mount this in the top of the tank, and then I've got a straight connector that connects to that, and then I'll connect and cut a piece of this hose that will then go up and over, let's see, behind the instrument panel down, and then I've got a 45-degree connector here that will connect to the side of the airplane and, basically connect that hose to the fitting that I have on the outside of the airplane to be able to fill the tank. That's my plan. Obviously I spent a little bit more money on this than I planned, but I think this is going to look really nice and it's going to work really well. So it was really finding that quick disconnect to use and mount on the outside of the airplane that kind of made all this work, and it's kind of why I decided to go this route, because once I found that fitting that was going to work really well, I decided to just plumb everything to fit that. I thought I'd take just a quick video here of the fuel tank with the instrument panel out, just to show you how much room there actually is. You can completely get back in here easily. In fact, if I wasn't needing to take the tank out because I want to try and clean up the tank itself, I could easily work on that fill port there while the tank is still in the airplane. So I did want to show you that because, again, it's not as tight as you might think, and like I said, I can even unbolt the fuel tank, and I believe with the mount here, the stick here, and the throttle controls that I can turn that tank and still get it out, I believe. At least that's what I'm going to attempt to do. And taking the instrument panel out was fairly easy. Of course, I didn't have anything connected to it, so I didn't have to disconnect pitot lines and static lines and electrical connections. But it took me just taking the bracket off in the corner for the instrument panel. I was able to just slide it out one direction and pop it out. So let me go ahead and pull the fuel tank out, and we'll start working on that. Well, I have the fuel tank out, but I've made some major changes on what I'm going to do to finish off this fuel tank. I've got several issues. One is just an aesthetic issue with the fuel tank itself. I've tried to polish parts of this, and it is really difficult to do. I don't know if it's because of this type of resin, this polyester resin for this fuel tank. It just is not easy to polish. And I've got a lot of defects in here. I've got a lot of almost print through here where you can see some dry weave through here. I don't like the looks of it at all. And this was the prototype tank, so I was more worried about the shape and making sure that it actually fit and that it worked and things like that. The next fuel tanks that I do I'll spend a lot more time making sure that I don't have some of these glassing issues built into the tank. But the other issue that I have is this issue with fuel level. Obviously, we like to keep the tank polished and clear so that we can kind of see through it. Now, it's a little bit more difficult to see through this tank because it's this darker color, but you still can see through it. However, when you're sitting in the airplane and you've got your leg here, you've got your leg here, you've got the stick here, you cannot see what's in this tank below this level, which is, almost the halfway mark. And so I've been trying to figure out different ways of resolving this issue for me, because the biggest issue I have is running out of gas in this airplane. And so I know other people might not have this issue with a CriCri. If they got 6 gallons of gas in it and you can fly for 2.5 hours, you're always going to have fuel in it. You're not really taking it on cross countries and stuff like that. I've got basically 30 minutes of usable fuel, and I need to know exactly how much gas is in here. And it's not that I need to be able to visually see it, because again, I don't really care about seeing if it's this full. Is it below here? That's where I've got a problem. But most of what I'm going to be doing on my flights is doing everything by timing. I'm going to say, I'm going to start a timer in the airplane saying, hey, I've got 20 minutes of fuel. Let's go out 10 minutes. Let's come back 10 minutes, and let's make sure that we have enough fuel to, go around the pattern a couple times and land. And so I don't really have this issue where I need to be able to see how much gas is in the tank, because seeing how much gas is in the tank is at a level where I can't see it anyway. So what I've decided to do is to go ahead and gel coat the outside of this fuel tank. And so I picked up some white gel coat, and what I'm going to do is just white gel coat the whole outside of this. I can sand it and polish it. I can sand and polish the gel coat actually pretty easily, because I've done that before with the molds that I've done, and this is the same, basically the same gel coat that I'm using here. So I think I can go ahead and gel coat the outside of this, sand it, polish it, and make it look really pretty. But what I've decided to do then, obviously, is if I gel coat it, I can't see how much fuel's in it. Well, I started looking around trying to figure out, is there any way that I could use any kind of fuel level sensor in the fuel tank? And of course, you really can't put a float device in here because of the pickups for the engine are floating around in here, and if you're doing any aerobatics, they're going to get tangled up in the float. So I can't use that. There are some post style floats that you could stick down in here that just has a a float that just goes up and down a rod. That might work, but again, you've still got the fuel pickups which could wrap around it and cause conflicts with it. So I just didn't want to go with a float type device. So I started looking at these different electronic fuel tank sensors, and there's some, I think they're ultrasonic or something like that, but most of them are designed to mount on the bottom of the tank and shoot up through the fuel and tell the depth of the fuel that way. But I did find this device that's made by Holley. And so this is the company that obviously makes a lot of things for automobiles, including carburetors and things like that. But they make this floats or this fuel level sensor that uses laser, and it's designed to go from the top of the tank down, and they can do a tank as low as 4 inches deep up to, I think, I don't know, it's 12 inches deep or something like that. But what I decided to do was try and use this along with a fuel gauge, because I can just mount this on top where the gas cap is. And what I'm basically doing is making a fuel tank that is only being able to be filled from the outside of the airplane anyway. I'm getting rid of the gas cap and then going ahead and installing this laser fuel level sensor on top where the gas cap is, and then I will actually be able to use a fuel gauge. And I thought, well, maybe that's the best scenario for me, because I can tell when the tank's full, I can tell when the tank's empty, and of course there are adjustments on this laser fuel sensor. There's settings underneath here for empty, half full, and full that you actually program this, so that you can program it for the style of tank that you have and actually program it to say when the tank is empty, show when it's half full, and show when it's full, which is great. But what I ended up doing here is I had a 4-bolt 2 1/8 inch circle pattern hole that was used for this fill cap. Now the Holley system uses a 2 1/8 5-bolt pattern, but it's not a symmetrical pattern. They actually offset the angles of some of these screws around that 2 1/8, and I think it's to make sure that when you're installing a float, because this is supposed to replace basically a float in even an older style car, that you can't get it in there backwards. Now backwards doesn't matter for this at all, but the bolt pattern is supposed to match a standard float 5-bolt pattern, which is not a symmetrical pattern as far as the spacing of the bolt holes. So what I had to do then is make an adapter, which I did this on my lathe, to go from a 4-bolt pattern to a 5-bolt pattern. But in addition to that, I had to make sure that this was as small as possible, because I do have an issue with the stick brake handle almost hitting this. Now it cleared the gas cap that was here, and this is only slightly bigger, and it seems like it's going to clear also, so it doesn't seem like I'm going to have any issues with installing this on top of here. But I made this, the gasket that's on the bottom is actually the one that came out of the cap here. There was a gasket here. I just made the exact same recess in my piece that I'm adding on here as an adapter, and put the gasket in here, and then this will fit on here like so, and I can put the bolts in and screw them down underneath here, because the issue I have with the 5-bolt pattern is that you will always end up with at least one bolt that interferes with another bolt, and if you try and miss or get to the edge of one bolt, you'll hit another bolt. So there's no way to get a single flat piece that I could screw the 4-bolt pattern into and the 5-bolt pattern into, unless I stepped it like this. So that's what I ended up doing. I stepped it, tried to make it as short as possible, making it so that I could then do that with the 4-bolt pattern, and that will pretty much stay on there all the time. Once I get that bolted on, that won't come off, and then the Holley unit will just bolt right on the top there and replace the cap that I had here. So I think this is going to work well. This will be able to connect directly to a fuel gauge that I purchased, and I'll be able to see and program this to exactly the fuel level in the fuel tank. So we've got kind of a modern method of actually reading fuel in a CriCri fuel tank. And if you look down the hole here, I don't know if you can see it, but the square recessed part right in the center there is directly below where the fill cap is, so that actually is a perfect spot to mount the fuel gauge. So that's what I'm planning to do. So I am going to take this tank all apart now. I'm going to go ahead and take this back off, even though I had put the RTV sealant and stuff in here. I'm going to pull everything out of it. I'm going to drill the hole bigger here for my my fill port that's going to go here that uses the ANN6 that's going to go outside of the airplane. So I'm going to try and get this tank now all cleaned up, gel coated, polished, and the new fittings in here. We'll get this all put back together, and then I'll go ahead and bolt this basically permanently onto the fuel tank, and then we'll put the fuel tank back in the airplane for the last time permanently, and then at any point I can just go ahead and screw this down on the top. I did thread these. It's just a number 10 bolts that came with it that fit directly in here. So I almost forgot to show this to you. I did get this in the mail, and this is the ANN6. They call it a zero brake connector, or dry brake connector. It's kind of like what's used on. The reason I got this idea is I used to work with tractors and equipment that had hydraulic lines that you took on and off for implements on the tractor, and they had quick connectors on there that allowed you to pull them off, and they didn't leak then once you took them apart because they had sealing devices on both ends. That's exactly what this is, and this is what I'm going to use for my fill port on the outside of the airplane. I don't know if I can get this apart with one hand. Oh, I can, yeah. Okay, so it's two pieces, and you can see it seals off when you pull this off. This is going to be connected to a hose that I can plug into the side of the airplane, twist, and then fill up the airplane. And then what I need to do is figure out a mount for this inside the airplane on the side of the fuselage that I want to mount basically flush with the outside. I'd like to figure out if I can make some kind of a cap that would be spring-loaded and twist lock on here to just cover it. That could be popped off on the outside of the airplane, but I haven't figured out if I'm going to do that or not. It'd be nice to have have a completely covered cap so that this wouldn't get dirty or anything. But that's basically how this works. And I think this will work really well for being able to fill up this fuel tank from outside the airplane. This is going to be the mounting plate that mounts on the inside of the airplane. I figured somewhere between frame 2 and frame 3 that would stick out the side of the airplane. And the way I designed this is that these other pieces go together here, and I'll see if I can do this with one hand and get this together. But this fits inside of here. I do have a gasket that goes on there. This goes inside of this, and then there's a part here that I cut a nut out of because I needed to prevent this from coming out the back end from turning. So I've got 2 bolts that go on here, and this basically just fits like this and bolts together with these 2 screws and a washer in the middle. And so this can be mounted flush from inside the airplane to the outside of the airplane, and I then have the ability to remotely fill and attach a fill line to the outside of the airplane. And then this is the hose that's going to attach to this on one side. It's going to go up around the cowl in front of the cowling behind the instrument panel, and then attach to the top of the fuel tank here to fill it from this point. But I think this is going to work really well for my setup. Again, I wouldn't recommend anybody else do this, but because I'm using these turboprop engines, I think this is a good solution. I'm always going to be flying and landing at the same airport because I just can't go any further. It's not safe. It's really going to be designed to just go around the pattern and stay within I'm assuming a 5-mile radius of the airport, which is what I intended this to be to begin with. So it's fine. But I just wanted to show you all this because these are all modifications that I'm doing to mine, and it's all additions that I've done since I finished the fuel tank and got it installed in the airplane. I've just decided, you know what, I don't want fuel in the airplane. I want to make the tank look nicer, and I think this fuel tank sender is going to be interesting to see how it works, because if it works like I think it will, having a fuel gauge in the airplane, I think it's going to work great. So I'm going to go install this on the airplane, and I'll show you what it looks like just so you can see exactly where I'm putting this, and I'll go do that now and be right back. So before I actually install this, you can see where I created the holes for the rivets and the actual hole to install the external fuel filler. I did it basically as close to frame 2 almost as I could, and just below the support that's underneath here, what you can see from the inside here. Yeah, you can see it up in there. I tried to get as close to there, but yet underneath that upper fuselage rail. It seems like a good position. I had to keep it far enough back that it was, plenty behind the instrument panel and wasn't going to get in the way of anything else. So let me go ahead and Cleco this in here, and I'll show you what it looks like. Oh, you can see I've just got this Clecoed on the side of the airplane, and I just slipped this in here. But this is the connector that would go in here, and you could twist on and fill this. I did make a cap that would fit on there too, that you could put a remove before flight flag on, so if I wanted to protect any debris from getting in here, I could do that with this cap if I wanted to. But I figured this would just stay exposed during flight. It's flush with the outside of the airplane, so I don't think it's going to be an issue during flight. And this will probably be bonded on the inside, so I'll probably glue it and then go ahead and just put some pop rivets in there to hold it. But you can see on the inside, that's what it looks like way back there, and you can see the hose that goes up, and then it's going to come down and attach to the fuel tank there in the back. I just finished some filling and sanding on the tank here. Most of it just needed to be done around where the seam was, where I put the two halves together, but I've got it all sanded down and ready for the first coat of gel coat. So that's what I'm going to do next, is just use some white gel coat, paint it white, and I'm going to use multiple layers and probably have to flip it over, do the bottom side first, and then flip it over and do the top side, just to make sure I get it completely covered. But I'll show you what it looks like when it's done. I'm just going to go ahead and paint this. It's going to take me probably a day or two, between drying and all the layers I'm going to have to do. And then I'm going to sand it when it's done, and then buff it and polish it, so it's should look pretty good, but we'll see. Let me go ahead and start the first coat. So a quick fuel tank update. I did a lot of sanding and tried to finish the fuel tank in white gel coat. Now, I ran into a bunch of problems with that, and I've actually switched gears here and decided I'm going to do something else to finish this. But I ended up buying white gel coat, but this is the gel coat that has the wax in it. And of course, if you know about gel coats and resin, if you get the wax in it, it means that it is going to completely harden. So if you want to add additional layers on top of it, you have to completely sand it. And since I only had the ability to brush this on, and I only was able to do one side at a time, in other words, I started with the bottom, I flipped it upside down, put a coat of gel coat on it, sanded it, put another coat on, sanded it, put another coat on, sanded it. I got through 4 coats, and even after 4 coats, even trying to be very careful and using 600 grit sandpaper, I still burned through, in a few spots. Like you'd see spots like this that would show up where you could see through the gel coat and see the fuel tank in it. Now, I should have just bought white gel coat without wax in it, so that I could put on multiple layers without sanding in between to build up enough, and then likely done a final coat with wax in it, so that it would harden, and then I could sand the entire thing. Now, I don't want to go out and buy more gel coat. This was really a hassle to do to begin with, because I have to do this in 2 steps. I have to do the bottom separate from the top, because I can't just sand the whole tank at once and coat the whole tank at once. It was still going to take multiple coats. It was going to take tons of sanding and finishing and polishing, and going through 600, 1000 grit, 1500, 2000 grit, polishing and all of that. And I just decided it's not worth it for this. I'm just trying to get this thing a solid color and have it look nice. So what I did purchase is, I've used not this brand before, but I have used other topside paints for like fiberglass boats, and it's worked very, very well. So I just got a single part easy epoxy polyurethane topside paint, and what I'm going to do is just use that and paint this entire fuel tank. I did put 1 coat of the white gel coat on top of the tank, and then I just completely sanded it down just to get it nice and smooth, but that should coat then very well with the paint, and I'm not too worried about this getting damaged, scratched, or anything, and even if it does, I can just repaint it. It's not a big deal. So again, I decided it's just not worth all the hassle to continue trying to gel coat the surface of this tank. I just want to get it painted white. So
Before I got that finished, I wanted to test my fuel sender that I got, which is this Holley easy level fuel sender. Again, it's designed for the automotive market, but it uses LiDAR, which is a laser technology, to sense where the top of the fuel is in the fuel tank. Now, it's taken me a lot of hassle and a lot of testing and setup to actually get this to work, and it's primarily because the instructions are not very clear on which gauges you can use it for. It does tell you you can use it with autometer, for example, and it does give you instructions on how to set that up, but I don't know if it works with all the other gauges that are out there. I did buy a cheap one off of Amazon, a digital gauge. I couldn't get that to work just because, again, you're supposed to set up that gauge to match what sending unit you have, and in this case, you have to set up the sending unit for what gauge you have. It's kind of the cart before the horse, chicken before the egg situation. Now, the gauge that I previously purchased, I believe I could have used, but I would have had to set that gauge up to a very specific ohm setting for empty tank and full tank. And for example, these instructions here will show you all of the different senders and what the ohm range is for empty to full for Chrysler, GM, Ford, all these different fuel senders. And I think if I would have gotten that, if I would have taken that gauge and actually programmed that gauge with resistors and setting the resistors to say 0 when it's empty for ohms and 90 ohms when it's full, I could have programmed the gauge, and then once the gauge was programmed, I could have set it up with this, because this you actually program the gauge to say, okay, well, tell me when the gauge says empty and I'll program this. Tell me when the gauge is full, I'll program this. But again, you have to have your gauge already set up. So in this case, it did say that it worked with all autometer gauges, or basically most of them. If you have what they call a standard gauge, which only moves 90 degrees, it's the short throw, you can simply, I believe, use any gauge you want regardless, because you do have to purchase the gauges usually with one of these ohm settings, but it seems to work with all of them, because what you do is then whatever gauge you have, you use this device, and you use this device to move the gauge up and down to 0, and then you set it, you move this up to half, you set it, you move this to full, and you set it, and you can program then this to work, I believe, with any of the autometer gauges that are set up for, you know, all these different ohm settings for different senders. So anyway, I bought what they call a long throw gauge from Autometer. So it's you know, it goes, I think, 270 degrees or something like that. It's a little more detailed then. You can see a little bit more resolution. Now there are some different things I had to do to set this up to work with that, because I had to program this then to use, I believe it's the Ford settings, which is 16 ohms to 158 ohms, which I was able to do that with this gauge, because this gauge actually works with all of these, and there's actually a way through using the wires and shorting things that you can set this thing up to whatever sender you're using. But the manual says, okay, set it up for the Ford, which I did. You have to also put in a resistor between ground and the sensor wire, which is supposed to be 680 ohms, I believe. And I believe that's some kind of pull down resistor, so that when the signal comes out of here, it grounds it properly and, you know, gets it correct. But then I also had to do some more things to get this gauge to work, where I had to hook up a voltmeter to it, and you have to check the volts on the sending wire and set this to the low tank level, do the same thing for the medium tank level and the high tank level, and program this at different voltages to work with the long throw autometer gauges. But again, I got it working. It seems to be working correctly now. I ran into another problem too, where yesterday I was getting really frustrated because I got it programmed, and then I thought I would be smart and take my fuel tank and put 3 gallons of fuel in it. It's a 6-gallon tank. I thought, okay, I'm going to put 3 gallons of water in it, because I'm still cleaning out the tank. It's not a big deal. I'm not going to leave any water in it. I can just dump it out and dry it out and clean it out. And I wanted to figure out where basically half full was in the tank with 3 gallons in it. And because this tank carries a lot more gas in the bottom than it does in the top, obviously 3 gallons of gas does not fill the tank halfway up. 3 gallons of gas actually only goes up about 3¼ inches above the bottom of the tank, and then you still have like 7 inches up to the top of the tank. So I wanted to figure out where half tank was, so that when I was doing all of this, I could check it with the gauge to see, well, what does the gauge say when the tank is actually half full?
So the problems I had yesterday though is that the gauge, once I got it set up and programmed, and you can actually program the depth of the tank outside of the tank. So this is sending a laser signal. It's bouncing off of something here. I'm just using this box. I can do full tank simulation here. I can measure with a tape measure the distance to the bottom of the tank, set it up here, and I can do half full and set it up here. So I can use this then to check the depth of the tank, and it will reflect off of here, and it will change on the gauge. You'll see it actually changes fairly slowly. It's got some kind of restriction in the gauge where it doesn't just jump all over the place. It actually controls how fast it will change. There's some settings on this to control that too, but it doesn't seem to affect this gauge because built in this gauge has that already pre-programmed into it. You can see it's going back down now because I pulled this out, but it'll take a while to get to the actual position. Well, anyway, so I stuck this on top of the tank to check half full and see if it would show half full here. It would get close to half full, but then it would start varying almost an eighth of a tank. It was like every minute it would just start creeping up, and then it would creep down, and it would creep up, like once a minute, once every 2 minutes. It wasn't fast, it was very slow, but it was very frustrating, and I started measuring with the voltmeter to check and figure out, okay, well, what is the voltage saying that's coming out of this? And it was varying, it was going up, and it was going down, and, it's tenths of a volt. It wasn't a lot, but it was very frustrating because I'm like, I'm not getting an accurate fixed reading when the tank isn't moving. There's water in it. There's, nothing's moving. So it should be just stopped at whatever setting. Well, it turns out I figured out that water is not a good substance to use in place of gas because water is too transparent and the laser does not bounce off the surface of the water like it does with gasoline. So once I determined that the water was the issue in the tank that was causing the problems, I reprogrammed this all again this morning, was able to get it all set up, and now it's actually seems to be working perfectly. I've measured from the top of this to where the top of the gas should be in the tank. I've used this to set that setting. I've gone all the way to the bottom and left, I think, 5/8 of an inch of gas kind of past what is the bottom setting measurement from here to here so that I have a tiny bit of reserve when this actually shows empty. And then again, I measured down the tank to figure out where that level was at half. And then if I move this to wherever it is at half level, this actually shows about 3/8 of a tank. And again, because this is showing the distance the gas is from the top of the tank to the level of the gas, not the volume of gas. So this is always going to be off anywhere in the middle as far as how much gas I actually have left. It's going to say I have less gas than I actually do because it'll get down to 3/8 of a, say 3/8 of a tank, but that's actually about my half level because again, there's not a lot of gas that's stored up here in the top part, and you use that up, and then you get down to the bottom here, and there's a lot of gas down here. So that's fine. I'm not too concerned about it because as long as I know that, it's no different than me looking at the outside, looking at the tank and going, oh, the gas is all the way down here. I must be 3/4 gone. No, because again, there's more gas down there. So even if I could see through the tank, I'd still have to make that mental note in my head that, oh, it's down to here, but that's, way more than half the distance, but it's, half a tank. Now it also does show you though, if you're sitting in the airplane, your legs are here, the stick is here. How are you seeing the gas way down here? I mean, when I get down to halfway, the gas is about, I think, here somewhere. I think I measured it and it's 3¼ inches. Just check and see. Yeah, I mean 3½ is right here at the seam, right about here. And that's telling me that that's almost the halfway full mark. I wouldn't be able to tell gas below that or even at that point. I could tell if the tank was maybe half full, but again, using a laser with this is going to be much more, it'll give me more information anyway, and at least this will tell me exactly when the tank is completely full because it doesn't hit F until the gas is all the way up here at the top of the tank. And of course it's not going to show E until it's all the way down to the bottom with about 5/8 of an inch of gas left, which is actually, there's a little, I can't pick it up right now because it's got the water in it, but there's the little square part in the middle of the tank on the bottom where the pickups will fall, and there'll be at least 5/8 of an inch of gas in there when this actually shows E. So again, it's good information. I think it's a good alternative setup. I think this is going to work out pretty well. And the only negatives I've heard about this is that
first of all, you have to figure out which gauges it's actually going to work with and how to program it, because it's a little bit complicated. But it also doesn't work well with aluminum tanks because, and of course, it's kind of deceptive because Holly says it does work with aluminum tanks, but doesn't work with shiny stainless steel tanks. But in practical testing, from what I've seen from reviews on YouTube, having an aluminum tank, especially when it's brand new, is very shiny on the bottom, and the laser will tend to go through the gas surface and reflect off the bottom of the tank and give you a false reading. And as the gas gets lower in the tank, it's less reliable. Some people will say, well, it goes down, you know, it works well down to about 3/4 of a tank, but then once it ges below 3/4 of a tank, it starts bouncing off the bottom of the tank, and the gauge just slowly goes down to zero, even though, you know, you're not using any more gas. So again, there's some limitations to this technology, but I think for using it in my airplane, it's going to work great. So what I'm doing now is I got the paint today. I'm going to go ahead and clean the tank out, and I'm going to go ahead and paint the outside of the tank, try and get it, you know, looking nice. I've already got this all programmed, so this is ready to go. So once the tank is done, I'll be able to assemble this all together, including my fill ports, which I've now got on the outside of the airplane. I've got the hose going, and I just need to attach the fitting to here, and we can get, I'm not sure where that fitting, oh, here it is. Oops. You know, I can go ahead and install this on the top, and that's my fill port fitting. And so once I have the tank painted, I'm going to go ahead and install it in the airplane for the last time. I'm planning on not taking it out again after this. And then I can go ahead and hook up the fill line. I can then start getting the overflow or the vent line connected. Gonna go ahead and get this installed on top of the tank, which over here I've got the, you know, fitting that I created to attach this to the top like that. And then I'm just gonna have to figure out where I'm gonna install the gauge. I'm thinking I'm gonna install it, you know, right behind this. I'm hoping between the dash and this, if there's enough space, which would be, you know, right back in here. I think I can get it. This line's going to come up and go attached to the fill line, so I think I've got enough space right back here to have that gauge sitting and hopefully attached to the tank rather than the instrument panel, so I can still get the instrument panel out without taking the gauge off. But so here's the tank. I just finished painting it. I did 3 coats on the bottom, and then flipped it over and did 3 coats on the top, and then in between each coat I sanded it with 600 grit wet dry sandpaper. I absolutely love this paint. This is easy epoxy polyurethane, and again, like I said before, it's a topside boat paint. It's what's nice about it is it takes a long time to dry, first of all, so it's like 12 to 16 hours, so you can only really coat it once a day, which is not that big a deal. But it is very hard when it dries, and it's very shiny when it dries. So it's very easy to wet sand and get a very smooth finish. So I'm extremely happy with how this is coming out. Now I just have to prevent it from getting scratched once it's in the airplane. But yeah, very happy with this. So I'm going to go start working on some of the fuel line plumbing next. I've made a couple additional changes I want to show you. So before I put the fuel tank in, I've decided to move the fuel shutoff valves. Now originally these valves are supposed to be attached to the rear side of the tank, but because I've got not only lines going into the tank, I've got 2 return lines that I need for fuel going back into the tank, I just didn't want to clutter the back of the tank too much, and it's very hard to reach behind the tank to shut those off. And I thought, well, maybe it'd be better if I just put them near the instrument panel. Of course, that was a dumb idea because you can't have fuel lines that could potentially leak anywhere onto any electrical components, and having those on the instrument panel just was not going to work. So I've decided to relocate these valves. So these are the 3/16 valves that I have for my fuel lines. They're very small because, again, the RC engines that I'm using don't require, you know, large fuel lines. And then I had these support clamps that basically hold it in place like I had on the instrument panel. And what I'm going to do is just reposition these onto frame 2, where I have this marked here, so that I can reach in and turn the fuel line off for the left engine here, and then I'll do the same thing over there and install another one on that side for the right engine. Anyway, I think this will be a good solution because I can still reach underneath the instrument panel. It's not going to be too hard to go down here and turn these on and off from even standing out here outside the airplane. So that's my plan right now. Is I'm just going to get these holes drilled and go ahead and get these
these two mounted before I'm ready to reinstall the fuel tank. Well, I finished drilling the holes and mounting the shutoff valves. You can see the right one over there on frame 2, and over there's the left one on frame 2. So I think that's going to work out pretty well. Like I said, it's fairly easy to just reach in here and just turn these off. And I did end up making a template. I was able to locate the center hole where I wanted to it and mark it onto frame 2 there, but then I just used a Clico to hold this onto frame 2 and use the other 2 holes that I pre-drilled into this as a template. That worked out pretty well because it was almost impossible for me to try and get a drill back in there and accurately drill those other 2 holes for the mounts that I had created. So I'm finishing up a few of the things on the fuel tank before I install it for the last time. I installed the NN6 fill port here on the top of the tank. I installed the vent connection here that's on the top. And then this is actually the plate that fits over my drum sander for the different drum sizes. Believe it or not, the holes actually lined up perfectly. So I screwed this down to the top and just used this as a template to remove the paint that was underneath here around the lip, because the fuel sender has an O-ring on the bottom of it that's slightly larger than this opening, and the paint that was on the inside here would have been exposed to the fuel that was, you know, on the inside of the O-ring and inside the tank. So I did want to remove that paint because this paint is not considered to be fuel resistant, and so I didn't want any of that paint on the outside here to soften and, you know, end up in the tank. So went in and did that. I'll just pull this off and then bolt the fuel sender down. And the other thing I have to do is reinstall the pickup plate that goes on the back here. I had this installed before with this gasket maker, which is fuel resistant. So I'm going to go ahead and just put some on the back of here and go ahead and get the pickups in there and screw this back down. So I got the tank all put back together here, but I decided I did want to try and pressure test it. So I just connected a gauge up to my my fill port on the top. I just ran these hoses all together just to, you know, basically cap them off with each other, and then had one hose here that connected to an air compressor. And I just pumped this up with about 2 psi. I didn't want to go any higher than that. On a fiberglass tank, they kind of recommend you stay at 2.5 psi, somewhere around there. But I'm just going to let this sit and see if the air drains out of it. If it does, I'll put a little pressure back into it, and I'll just go around and check all my fittings and connections and make sure that that there's nothing leaking out anywhere that it shouldn't. So it's already been several hours here. So what I've decided to do is not wait overnight. I really want to get this fuel tank installed tonight. So I'm going to go ahead and just spray everything down on the top here with some soapy water, just to see if there's any bubbles coming out anywhere. I don't believe there is. I don't think it's leaking at all. So I'm pretty confident in the sealant and everything that I did on the bolts. So let me try that. Then I'll clean it all off, and I'm going to go ahead and put this back in the airplane. Well, there you go. I got a leak. So I was a little too overconfident. I'm glad I checked with the soapy water, but you can see the bubbles coming out. It's actually coming out of this fitting around the threads, so it's coming out of the threads at the top of the nut. I did notice right when I turned the camera off a minute ago that this was leaking on the backside here on my fuel tank sender, and also around one of these screws on top. Now, what I had done is when I initially attached this to the fitting here on the bottom that attached to the top of the tank, and I was testing the fit of the the gauge here, I didn't tighten these screws in the back, so it was leaking a little bit down here and leaking around the screws, but I went in and tightened those up, and that stopped that from leaking. So the only thing we have to fix is the vent fitting here that's on the tank. So I ended up taking this vent fitting out, and believe it or not, I forgot to put the washer on the back side of it when I pulled it up through the tank. So I pulled this completely out, cleaned out inside the tank underneath it, put sealant on there, and then put the washer on there, and then put it back together. And I've sprayed everything down. It doesn't seem to be leaking at all, maintaining 2 psi like I put in there originally. But yeah, I'm not seeing any bubbles anywhere. So I think put one more coat on here real quick. anyway, I'm going to let this sit a little while just to make sure that no bubbles start coming out, but otherwise I'm going to say this is done and I can go ahead and get this installed back in the airplane for the last time. So I've got the tank now all ready to go back in. I have one last thing I need to do before I do that, and that's put this foam on the bottom of the tank to try and provide a little bit of cushion between frame 2 and frame 3 on the bottom of the tank. I'm going to put that right in this crevice here, about halfway in. This is where frame 2 rests, so frame 2 will, you know, go up the side here and go across the bottom here. And then frame 3 up here, I'm just going to put it again along this inner radius here. So here's what these seals look like now that they're installed. I peeled the paper off of both sides. Now it's only sticky on one side. It's sticky on the side I attached to the tank. This side is not sticky, so this will just rest on top of the frames inside the airplane. So let me go set up the camera. Let's see if we can get this tank installed. So I'm ready to put the tank back in here, and I want to see if I could videotape this. It's a bit of a difficult process, but I think I remember the steps. I did try and put some tape on a few things. The part that scratches up the tank the most is if you catch it back here on this frame 2. Obviously I have these mounts back here for my ECUs, but also the bottom of frame 2 can be a little bit of a problem. But the main thing is these pulleys down here for the rudder pedals and the steering. These have to be kind of bent out of the way in order to get the corners of the fuel tank in, and I'm going to try and take some rags and cover those up before I start this process. But yeah, I got to try and keep from scraping it here, scraping it up here, scraping it back there, scraping it down here on the bottom, and scraping the corners. So I wasn't very successful the last time I test fit this in here. I kind of scratched it up in a few spots, but you know, luckily it's on the bottom and you don't see it. So yeah, let me see if I can set up the camera and get a fairly decent angle of trying to get this tank in here. Alright, so I've got the fuel tank, and I haven't installed this before with the mount on the top for the fuel sender, but I don't think that's going to be a problem. So let's see, when I've done this before, I think I start this way. And we got to get around the stick, and we got to get around the top here, and you can see it just, I mean, literally just barely clears the top as it goes down in here. Now, once it gets down in here, I have to try and tilt it so that the bottom goes underneath frame 2 in the back. Just set it there a second. Change positions here, because you have to get it all the way down in here and turned enough that is not quite it. There we go. Okay. Okay, so now I have it turned in here, but now I actually have to pull it back up past frame 2 and then back down. Let's see here. There we go. Finally. Let me see, and I do have a, I guess I'll just start here on the hip. There we go. Now I can pull the towels out. Okay, no scratches on the top, so that's good. It's in there. Okay. Yeah, so the tank is in now. I still have to get, obviously, the screw in the back and the supports on the side here bolted down. But so I thought I'd do one last video here just showing the fuel tank completely installed. I've got the fuel sender and the fuel gauge all attached there. That looks like it's going to work really well. And then let me take the panel down here, and you can see I did connect a vent line to that nipple connection that was on top of the tank, and I just tie strapped it to the fill line that goes out the side of the airplane, and you can see that it's up there, comes down just in front of frame 2 And then I made these little orange clips on my 3D printer, and they're just attached with a single 3/32 pop rivet, but it allowed me to just route that hose between frame 2 and frame 3 here, and it's just clipped in. And actually, these clips are really nice because it actually holds it really tight and it snaps in really nicely. But then I ran it down to the nipple connection that I put just to the left of the air intake for the cockpit down there. I wanted to make sure that it was in front of those nut plates down there, because that's where the cover that goes underneath, goes over the landing gear underneath the airplane attaches. So it needed to be in front of that, but I wanted to make sure it was as far back as possible so that it couldn't, drip or have any fuel coming into those air intakes. But I think that's a good spot, because on the outside of the airplane, when I'm filling it up, that connection is right under here, and I'll be able to just either connect a little hose or put a bucket underneath it or something to catch the fuel that comes out when the tank is full. Because other than knowing from the fuel gauge that the tank is full, I'll know because fuel will come out this breather tube, and then I'll know it's actually completely full. So yeah, it's all installed. It looks great. Hopefully I can keep from scratching it up too much, but yeah, so that's the end of the fuel tank installation video. So thank you for watching, and please like the video and subscribe if you're not already subscribed, and I'll see you on the next video.